Well, all right. Welcome to Math Blossoms, where growing in mathematics is natural. Today's lesson topic is sequences of transformations on a coordinate plane. Let's get prepared for today's lesson. We're going to need a pencil, preferably with an eraser in case we make mistakes. Also some paper in order to take notes, and some graph paper, definitely, so that we can draw our transformations. And then a ruler or straight edge is optional, but might be useful if you would like to draw straighter lines. Don't forget to pause the video from time to time to answer practice questions, or rewind the video if you need to review anything before you try to answer some of the practice questions. All right, let's go ahead and grow our vocabulary, but before we do, I'm Miss G, and we'd like to start each lesson with 3 deep breaths in. Hold it in for a 3 count, and then we're going to exhale out our mouth. So breathe in through the nose, hold it for 3 counts, and then we'll exhale. As we do, let's try to get rid of all those random thoughts that might be in our mind, that might be keeping us from thinking about the mathematics that we need to focus on. So let's go ahead and take our first breath. Hold it for 1, 2, 3, and breathe out your mouth. Okay, let's take breath number 2. Breathe in your nose. Hold it for 1, 2, 3. Breathe out your mouth. And the last breath, breathe in through your nose. Hold it for 1, 2, 3. Breathe out your mouth. All right, good. Let's go over our vocabulary words that we may see today during the lesson. The first one is a coordinate plane, and that is what you're looking at here, the graph or grid pattern that's divided into 4 quadrants or 4 sections by 2 axis lines with a center point in the middle. A transformation is where a process by which we change a shape on a coordinate plane by either changing its location, its orientation, or the size of the shape. Origin is the center point of our coordinate plane, and it is right here, the point 0, 0 ordered pair. The x-axis is our horizontal axis, which goes right, left, right here in the middle. And then the y-axis is our vertical axis, which goes up and down, or down to up. Ordered pairs are how we write our coordinate points numerically. The x is our indication of how far to go left or right, and the y is our indication of how far to go up or down before graphing a point. Sequences of transformation, or a sequence of transformations, is simply multiple transformations or more than one transformation happening, one right after the other. Another word you may see is composite transformations. That's another way of saying sequence of transformations. A scale factor is what we use when we do dilations. A dilation is when we make a figure larger or smaller. So it's a type of non-rigid transformation, and we use a scale factor to multiply the coordinate points by in order to make the shape bigger or to make the shape smaller. A reflection, a rotation, and a translation, those are our 3 rigid transformations. So the size does not change when we reflect, rotate, or translate. A reflection is a turn, and we can turn it 90 degrees, 180, 270 degrees, or a full 360 degrees. A reflection is a flip, so that would be like a flipping over an axis line of some kind. We're going to use the X or Y axis for most of our reflections. However, I am going to show you one example of a line that's not the axis line in this lesson that we can reflect a figure over. And then a translation is a slide. So that's when we slide a figure left, right, up, or down. And then prime marks are how we indicate which transformation occurred first, second, third. It's a way for us to tell in which order they occurred, which came first and which came second. All right, we have 3 essential questions that we're going to talk about today. The first one is define a sequence of transformations on a 2-dimensional coordinate plane. How can you determine the order of each transformation in the sequence? Explain two strategies that can help determine which transformations happened in the sequence. Okay, so sequences of transformation. So here we have this figure. And let me go ahead and read this for you first. A sequence of transformations, otherwise known as composite transformations, is when a geometric shape has been transformed more than once on a two-dimensional coordinate plane. There are some strategies you can use to determine which transformations have taken place. So here we have the original figure in green, and judging from the way this looks in step one, the red rectangle here, this green rectangle looks like it was just translated. So it looks like it just went right and then down a little bit in order to get to step one. And then in order to get from step one down here to the light blue rectangle, step two, two things could have happened. It could have just been another translation. It could have just been a slide all the way down this way. Or it could have actually been a reflection, because remember, reflections are always equidistant to the line of reflection that it flips over. So notice all of these points here are 4 spaces from this line of reflection, this one, and also this one and this one. So because we don't see how the endpoints are oriented, it's impossible from this figure to tell whether it was reflected or if it was translated. But it could have been either one of those in order to get from the red to the light blue. And then the light blue one turned into the purple one here by a 90-degree clockwise rotation. I can tell this because of the orientation. We've got a 2-unit side here and here on the light blue triangle. Well, that 2-unit side is now on the top and bottom instead of the left and right. So definitely the orientation changed when this was turned by a rotation. And then from step 3 to step 4, this looks like another translation where it was just a slide to the right and then a slide up as well. And then from step 4 to step 5, this the only thing it could be is a dilation, because of obviously step 5 is the larger blue triangle and it's much larger than the pink triangle. So definitely a dilation occurred here. So in this figure, we have 5 different transformations happening, and of course there's several different ways you can kind of determine what has happened, and sometimes it's a little bit of trial and error, and sometimes you can have more than one answer. Like in this step 1 and step 2, it could have been one or some, it could have been a translation or a reflection. So we'll look out for that in some of the practice ones that we do today. A sequence of transformations may create congruent or similar shapes depending on what types of transformations happen. So what that means is, congruent shapes are always equal to one another. And if you haven't checked out that video yet, I do go into a little bit greater detail on the difference between congruent and similar on the congruent geometric shapes, congruent or similar video. So if you haven't watched that one, you may want to watch that one before doing this one. But the only one that really created a similar shape was the pink turned into this dark blue rectangle here, which is much larger. And it does look like it's a similar shape based on the number of units on the corresponding sides. Now, the order in which the transformations takes place is important. So if we know the order, it does help us figure out what happened to the shape a little bit easier. So let's look at some of these examples. Okay, so we have these 3 triangles here. We have the light blue ABC, and notice how it was transformed from quadrant 1 all the way down to quadrant 4. Now this could have been it looks like it's either a rotation or a reflection. I know this because the C is on the bottom here, but now the C is on the top in the red triangle. So it looks just like it flipped over this x-axis. So it looks like a reflection here. If you listed the points, you can see that the y value of each of these points have changed signs. And remember, that's our rule for reflecting over the x-axis, is to change the y value to its opposite. So that looks like definitely a reflection over the x. After it reflected, it looks like it translated by sliding this way. Now, the reason I don't think it reflected or rotated is because the orientation is still the same. The C is still on the top. and it originated on top here in the red triangle, and now it's still on the top. The B and the A are still in the same location. So because the orientation didn't change, the only thing it could be is a translation. Okay, this one here, three other triangles. I'm going to go down to the bottom here. It looks like it was a slide to the right, and it does tell you that it moved over 10 to the right. And then from this triangle to this triangle here, again, another reflection over that x-axis because the B is on the bottom here, and originally it was on the top. Now notice we do have our prime marks on both of these figures where the original pre-image had no prime marks. The first transformation had one prime mark, and then the second transformation has two prime marks, and that's how we can tell which order that they occur in. Now the rectangles here, we started off with this pre-image here, and the one prime mark figure is this image, the smaller rectangle here. So what it looks like happened to me is that it rotated. So if it rotated, the two-sided edge here, the BA and the CD edge, those have now moved to the top and the bottom. So definitely the orientation changed, and it looks like it just went, boop, just kind of turned around that way, clockwise. Okay, once it got to this location, then it looks like it was dilated because this beigey yellow triangle here that overlaps it, that one's much larger. And so it looks like it's double the size actually. So it looks like it was dilated with a scale factor of 2 to become this larger rectangle. And that was our D double prime, C double prime, B double prime, A double prime rectangle. So the last transformation just looks like it was a translation. Looks like it was a slide to the right and then up a little because the orientation is still the same on the larger purple rectangle. And those have also, triple prime because it was transformed 3 times, 1, 2, and then 3. Okay, now this one's a little bit unique because I wanted to show you what it looked like when a figure reflects over a line that's not one of the axis lines. Now, this is not something we go into very deeply in the 8th grade content, but it can actually happen. So I just wanted to show you this line here that they have drawn. I'm just going to make it red so you can see a little better. This line here is called the x equals 2 line. Now, when we start studying linear equations, you will learn how to create an equation like this to represent a line. But for right now, just know that this is the line that this shape, this quadrilateral, looks like a little kite shape. This shape has reflected over this line here. And I can tell this by counting the spaces. So we have 1, 2, 3, 4 on this side of the x equals 2 line, and 1, 2, 3, 4 in order to make that D prime point. And if I followed C, I would count, 5 spaces on each side to get the C, and then 6 spaces on each side to get the B, and so forth. Because all of these are equidistant on this, on either side of this line, I know that it has been reflected. Also, the orientation is different. Notice it's C then D over here, and now it's D then C. So again, it did flip around in order for that to happen. Once it did reflect over this line, then it rotated to get to this shape here. So I know this again because the orientation changed once again. The DC that's on top of the figure is now on the right side, and the CB is now more on the bottom. So it did turn 90 degrees clockwise in order to get from this position to this position. In geometry, prime marks are used to show which geometric shape is the pre-image and the order in which the sequence of transformations happened. Okay, so how do you find the order of a sequence of transformations? The first strategy is to look for changes in size, position, and orientation of the shapes. If the size of the shapes are different, then a dilation has happened. If the, position has changed but not the orientation, then a translation has happened. And if the orientation has changed, then a reflection or a possible rotation has happened. So this is basically, how do we know which transformations occurred and in what order? Well, of course, the prime marks are going to help us figure out which one came first, second, and third. But if there's not a prime mark, then look for, changes in the position, the orientation. And then the second strategy is when we actually write down the points of the pre-image and compare it with the points from the image that has only one prime mark. Compare to see which transformation may have happened. So if I wrote the points down for this quadrilateral for ABC, and then wrote the points down for A prime, B prime, C prime, I'm going to see that a reflection occurred because it's going to fit the reflection rule for reflecting over the y-axis. And if we remember, the rule is that we change the x value to its opposite. So if you compare this C point with negative 5, 4 to this C point 5, 4, the only thing that changed was the x changed to its opposite sign. And that's true for all of the points on this on this quadrilateral. So if you see that going on, then you know it had to have been a reflection because it definitely fits that rule. After you figure out the first transformation, then you do it again. You take these points from the prime image and you look at the double prime image down here and compare to see what could have happened to follow this movement here. And this movement here was definitely a rotation clockwise 90. Because if you look at the rule, let's just take C for instance. C is a 5 and a 4 over here. So positive 5, positive 4. And remember the rule for rotating 90 degrees states that we take the X, we change it to its opposite sign, and then we flip the X and the Y around. So if I do that with C, I'm going to get 4 and then negative 5. And if you notice down here on the C point, you're seeing 4 and then negative 5. So, and that does work for every point on the quadrilateral. So it's definitely a 90-degree rotation. So this is how we can kind of tell mathematically and numerically what transformation takes place. Just compare the points and see, which rule did it follow? Did it follow the reflection rule? Did it follow the rotation rule? And then sometimes it's a translation. But remember, when it's translations, the orientation of the shapes of the points won't change, just the location. All right, so sometimes more than one answer is correct. So I'm showing you this figure here because this rectangle ABCD, it looks like it was a 180 rotation that got from this the second quadrant to this fourth quadrant. And I know that that can't be the case. And here's how I know, because these points here have double primes. On the green triangle, if there are double primes, that means something had to have occurred in between the blue and the green. So some other transformation occurred. It's just not showing on the graph. So it says, when deciding on which transformation occurred, sometimes more than one answer is correct. For example, rectangle ABCD, okay, looks like it was rotated 180 degrees clockwise or counterclockwise in the picture. This is not correct, though, because there are 2 prime marks on the image. So the 2 transformations took place instead of 1. It should be took. 2 transformations took place instead of 1. Rectangle ABCD had to have reflected. So I'm going to draw another triangle right here. I'm sorry, rectangle, not triangle. I'm going to draw this rectangle here, and it's red. And I'm going to label this C prime, B prime, D prime, and this one over here is A prime. Now, notice that this blue triangle had to have reflected over this x-axis in order for those points to be in those locations, okay? Now, once it reflected over the x, it reflected again over the y in order to become the green rectangle. And I know this because the D and the A, the C and the B is now turned around, so it's differently oriented than it was before. So the orientation changed from the blue to the red. The CB is on the bottom now instead of the top up here. And then again, the orientation changed when I flipped it over this y-axis line. to make the green rectangle, and the D and the A switched places and the B and the C switched places. So this was actually two reflections that just appeared to look like one 180 rotation. Now, if the prime marks were not located there, if we just had the blue triangle and the green triangle, then you could have listed both options as a possible answer. So if the prime marks weren't there and we couldn't tell which order, something came in, we could have said, well, this is a 180 rotation, but it could have also been two reflections, a reflection over the X and then the Y. Your turn to try and grow a blossom now. So let's look at which transformations took place. So we have triangle JKL in the blue. Then we have J prime, K prime, and L prime, which is the green triangle. And then J double prime, K double prime, L double prime, which is the purple. So I'm going to count to 3. Go ahead and pause and try to answer this one on your own before I give you the answer. 1, 2, 3. All right, so here's our table, and we've listed the pre-image points for the blue triangle, which was -1, 1, 0, 1, and -1, -3. Now, in order for the blue to become the green triangle, a dilation must have taken place because the triangle is bigger than the original blue triangle. And the dilation occurred as a scale factor of 2, because if you multiply these points times 2, you're going to get the new green triangle points. Now, after it was dilated, it turned into the purple triangle because of the double prime marks. And so what changed between the green and the purple? Well, it had to have been a reflection over the y-axis, because I know when it reflects over the y-axis, the orientation changes, and the when you reflect over the x, the y value changes, or excuse me, when you reflect over the y axis, the x values do change its sign. So if you look at the green triangle points, all of these x values change to the opposite sign, with the exception of the 0, because the 0 doesn't have a sign. But that does fit the reflection rule. And notice the K and the J, the J prime and the K prime is now K double prime, J double prime. So it did change its orientation there as well. All right, so let's do a second blossom. Which transformations took place? And feel free to use a table to help you. 1, 2, 3. Okay, so here's our table for this sequence of transformations. The green triangle, PQRS, we've listed the points, and then the blue larger rectangle here. Did I say triangle? It's a green rectangle, and then a larger blue rectangle. And this rectangle here, because it's bigger, we know it had to have been dilated. And if you work out the points, a scale factor of 2 is used, because if you multiply the green points times 2, you're going to get the blue points. So we know that it definitely dilated. It was a bigger rectangle, and it was dilated with a scale factor of 2. Now, once it did dilate, we have now changed it once again. So I wrote down the purple rectangle points for the P double prime, Q double prime, R double prime, S double prime. And judging from what occurred between the blue points and the purple points, I know that a rotation of 90 degrees clockwise must have happened. The reason I know this is because in order to change a point that is rotated 90 degrees clockwise, you change the x to its opposite sign, and then you flip the x and the y around. So if I did that to this blue point P prime, I'm going to get this purple prime 6, 4. Same with this one. If I change the x to its opposite, which would make it -2, then switch it, I'm going to get 6, -2. If I change this +2 to a negative and switch it, I'm going to get a -8, -2. If I change this -4 to a +4 and then switch it around, I'm going to get -8, +4. So definitely, after it was dilated, the last transformation was a 90-degree clockwise turn or rotation. Okay, let's try a third blossom. Which transformations took place here with these triangles? So go ahead and pause. I'll count to 3. 1, 2, 3. All right, so here's a table with our green triangle points, -3, 5, -5, 1, and -1, 3. And then listing the points for the prime shape, this the blue triangle right here, kind of purpley looking, A prime, B prime, and C prime. It looks like the orientation did not change at all. The A and the B and the C are in the same spots. A is on top, C is on the right, and B is on the bottom of this triangle. So in order for it to be a reflection or rotation, the orientation has to change. So I know this had to have been a translation. So since it was a translation, I'm going to just count to see how far it moved down, or and then how far it may have moved in either direction, right or left. And it looks like, looking just at the C point here, it moved 1, 2, 3, 4, 5 down, and then 1 to the left. So that would be in notation form. X, for every XY point, X is going to be -1 because we moved 1 left. And then Y is going to be -5 because we moved down 5. So it was definitely translated first. And then after it was translated, then it changed to the red triangle. So I've noted the red triangle here in purple. But these are the new points for the red triangle. And if you look at this, oh, there's a little typo right there. Scratch that out. Triangle ABC changed positions and also orientation. So it did change orientation, and it looks like it was definitely a reflection over this y-axis line. The reason I know is because the A and the C are now switched places. The C is on the left and the A is on the right. So it definitely changed orientation. And all of these points are equidistant to the line of reflection. This is 4 spaces to the line, and then the A double prime is 4 spaces to the line this way. C is 2 spaces to the line. C double prime is 2 spaces to the line. B prime is 1, 2, 3, 4, 5, 6 spaces, and then B double prime is 6 spaces this way. So it definitely reflected over this line. All right, so the fourth one is figure P was transformed twice to make figure Q. Which transformations took place, and use a table to help you. So this one had 2 transformations because it said it was transformed twice. So see if you can figure out what may have happened to P to become Q. Pause. 1, 2, 3. All right, so here's our points for the P pre-image, and I've noted that it was rotated 90 degrees clockwise for the first transformation. And the reason I wanted to rotate it clockwise first to see if that would work is because notice how the P has the 2 unit sides on the right and left, but the Q has the 2 unit sides on the top and bottom. So somehow this had to have turned to make the 2 side be on top and bottom. So if I turned it this way, 90 degrees clockwise, it's going to end up being, somewhere over here. Actually, I think I put it on there. Yeah, I did. So P double prime would be like right here. And then, of course, after it was rotated over here, then it was translated just down 5 spaces to get to, or sorry, I think it's 6 spaces. Let's count. 1, 2, 3, 4. Yeah, it was 6 spaces. That should be Y minus 6. There, not 5. So it's definitely translated down once it rotated and turned. Now again, when you're doing these sequence of transformations, sometimes you have to try a couple of things to get the points to work out right. So you may have tried like a reflection first and then realize that, oh, that reflection is not gonna make my figure go to the correct spot, or something like that. You may have tried a translation first, but just know that sometimes it does take a little while to figure these out. Some of them are more challenging than others, but the more you practice this, the better you get at it. Okay. The first essential question is define a sequence of transformations on a 2-dimensional coordinate plane. So let's pause and try to answer that question. All right, so the answer is a sequence of transformations or composite transformations is when a geometric shape has been transformed more than once on a 2-dimensional coordinate plane. All right, our second answer to the essential question, how can you determine the order of each transformation in the sequence? All right, first look for the prime marks on the preimage and the images to determine which shape came first. The shape without any prime marks would be the preimage, which is the original shape. The shape with one prime mark would be the shape after the first transformation, and the shape with two prime marks would be a shape after the second transformation, and the shape with three prime marks would be the shape after the third transformation, and so forth. Okay, so the third essential question, explain two strategies that can help determine which transformation happened in the sequence. Okay, the first strategy is look for changes in the size, position, and orientation of the shapes. If the size of the shapes are different, then a dilation has happened. If the position has changed but not the orientation, then a translation has happened. And if the orientation has changed, then a reflection or a rotation has happened. The second strategy is to write down the points from the pre-image and compare it with the points from the image that has only one prime mark. Compare to see which transformation rule may have happened. Next, compare the points of the image with one prime mark with the points of the image with the two prime marks, and then repeat if necessary if you have any shapes with three prime marks and so forth. All right, so we're here to review our vocabulary one more time with this adorable little frog here wearing a little blossom on his head. Our first word is coordinate plane, which is the grid pattern or graph divided into four sections by two axis lines with a center point. Our next word is transformation, which is the process by which we change a geometric shape by changing its position, location, orientation, or size. The origin is the point in the very center of our coordinate plane, or the point 0, 0. The x-axis is our horizontal axis, which goes left to right or right to left. And the y-axis is our vertical axis, which goes up, down, or down to up. Ordered pairs are how we list our coordinate points numerically, and the x always comes before the y, which is alphabetical. The x tells us how far left or right to go, and the y tells us how far up or down to go. A sequence of transformations is when we have more than one transformation occurring. And another word for sequence of transformations is composite transformations. A scale factor is the multiple that we use in order to dilate a figure, and dilating a figure means to or a dilation means to enlarge or make bigger a shape, or also a reduction, or to reduce the size or make smaller the shape. Dilations are non-rigid transformations because they do create similar shapes, not congruent ones. Now, reflections, rotations, and translations, they create congruent shapes because they are rigid transformations. Reflections are the flips, so it flips over a line of reflection. Rotations are turns. We can turn it 90 degrees, 180 degrees, 270 degrees, clockwise or counterclockwise. Translations are slides, so we can slide it left, right, up, or down. And then our prime marks are those little apostrophe looking marks that we place on point labels in order to determine which transformation came first, second, third, and so forth. All right, so a bouquet of math blossoms have opened up in your mind today. So to further improve your math language skills, remember to practice by doing your classwork and doing your homework. Study at least 10 minutes per day. Ask for help if you need it from a study buddy or from your teacher. Learn from your mistakes and don't be afraid to make them because it will happen. It happens to me even to this day. So if you make a mistake, don't worry. Just try to remember it so that you don't continue to make the same ones over and over. And then always try and do your best to it's called the math struggle when you're trying to struggle or grapple with a problem to try to understand it. That's part of learning math. So always try your best. And if you don't, quite get it the first time, give it some time, clear your mind, try again, and eventually you'll get there. All right, so I'm Miss G, and I just wanted to say thank you. And if you want to review some of these previous lessons in the series, they're all on a playlist called Transformations on the Coordinate Plane. If, there's several videos on rotations, translations, geometric congruence versus similar, things like that. So I recommend you do that. Now, our next unit that we're going to get into is rational and irrational numbers. So if you're looking for a new unit to get into, that's an unit about algebra. So enjoy. I enjoy teaching algebra. So geometry happens to be my favorite, I think, but algebra is a great branch of mathematics as well. So that one is the next one in line if you're looking for a video to watch next. Thank you so much. And now it's time for me to say it was lovely teaching you math today. Bye.